Plotly is an interactive visualization library in Python. It's different from other static plotting tools. Today, I am going to plot some charts and graphs using Plotly and compare those to our standard graph, which we plotted in our last video using Pandas built-in visualization tools. Please watch along if you find it interesting, or feel free to work alongside if you want to practice this course too. So let's get started. So here, let's start by importing some libraries. So here, we imported NumPy, Pandas, matplotlib.pyplot, cbound, and then we ran the one-line code %matplotlib inline, which helps to run the visualizations in the Jupyter notebook. Then we also imported cufflinks, and from plotly.offline we imported download underscore plotly.js, then init underscore notebook underscore mode, then plot and iplot. And then we ran init underscore notebook underscore mode using the parameter connected is equal to true. So what this does is it connects the Plotly to the Jupyter notebook, and we can run the Plotly codes directly from the Jupyter notebook and can see the visualizations here. If you want to host all the visualizations offline on your computer, you can, instead of using connected is equal to true, you can use connected is equal to false. Uh, but the downside of that is it will download the entire JavaScript to your local system, and that will take a bit of space. Then we also use cf.go offline method, and cufflinks basically helps to connect pandas data frame to plotly library, and thereby enables us to plot the interactive graph in the Jupyter notebook directly using the data frames just by calling the iplot method. Next, we will upload the tips dataset from the cbound repository. So as we know, cbound comes with some pre-uploaded datasets. One of the popular one of those is the tips dataset. So we have uploaded this and we will use it for our visualization today. So first up, let's check the head of the data frame and use the info method to check other attributes about this data frame. So as we see here, this data frame has a total of 244 entries ranging from 0 to 243, that is the range index, and in total it has 7 columns. First is total bill, then tip. These two are numerical columns. The data type is float, and then the next 4 columns are categorical regarding sex, smoker, day, and time. And the last column is the size of the group that came in. That is an integer data as well. And as you can see, none of these rows has any null data here. So next we will start plotting the graph. We will start with the line plot. We will do one thing, we will plot the graph for both using the pandas built-in visualization tool and then using the plotly library, and we'll compare the two. So let's plot it. So we got an error here, which was basically the plotly was trying to plot the line graph for all of the columns, which included the categorical data. So we need to limit our data frame just to the numerical columns here. Yes, so see what happened here. For the pandas method, we use df.plot and then we use the kind parameter for line argument, and that produce a line graph for all of the numerical columns. There was no need to specify the numerical columns here. The pandas was automatically able to detect and remove the categorical columns. And we use the figure size argument 12:3 to change the size of the graph we got earlier. Now this is completely static. We have the graph and we can see it, but we cannot infer any other information from this graph. For the Plotly method, we almost use the same kind of argument. We just sorted our data frame to just the numerical columns, and then in place of dot plot method, here we use the iplot method, and the argument within the method was same, which was we use the kind parameter for the line argument. So this produces the line graph for all of the numerical columns. But the beauty is, if you see the legends here, you can click on this and deselect. So suppose if you are presenting this graph to an audience, what you could do is you can select and deselect these lines. You can zoom into any part of the visualization for a closer look. You can also pan it, and that means you can move from one place to another within the visualization. You can use the zoom in, zoom out, and then you can go back to your auto scale. So this is a lot more interactive than the pandas graph, and also if you hover over the graph, it will give you the data at each point. So it's really useful. Now next, so what we could do here is, suppose we want to know the difference between the total bill and tip for all of the rows. So what we could do here is we could use this same argument, but instead of the parameter kind where we use the argument line, we could use the argument spread for this. So we have seen this line graph ever. It's the same thing, but what we have here as an additional row is this spread diagram. The spread is the difference at each coordinate between these two columns, that is total bill minus tip. So if you want to take a closer look, let's say we want to know the spread for this data at row 100. Let's zoom into this, and now at 100 we know our total bill was 11.35 and tip was 2.5. So what is the difference between that? Again, go to zoom, find the row 100 and the spread column and zoom into that. Here, and you can also move it to align it at the same place. Now if you see at 100 we had our data total bill as 11.35 and tip as 2.5. If you go to the spread column, we get the difference, which is 8.35. If you want to check for some other row, let's say we check here at row 102, the bill was 44.3 and the tip was just $2.5. So the difference between the bill and the tip was $41.8. Now these kind of graph, it may not make a lot of sense with this data, but this can be really useful for comparing financial data like stock informations. Let's say you want to see the difference between the return between Tesla compared to S&P 500 index, or if you want to compare interest rate spread between two different countries. So for those kind of data, the spread could be really useful. And see what we did here for this graph was we used almost similar kind of coding which we do for the pandas library. For the pandas we use df.plot. For this line graph we use df.iplot. And just the use of this single letter I all of a sudden produces a visualization which looks completely different from the static graph which the pandas produce, and make you seem like some sort of an amazing interactive data visualization programmer, while your secret was just to use this single I letter here after importing the Plotly libraries. So this is really cool, isn't it? So next, let's move on to scatter plot now. So for the scatter plot, unlike the line plot where we just give the kind argument, scatter plot is between two sets of data. So we need two columns for this. We will specify the columns as x and y, and then we will give some other parameters as well. So here this shows a relation between the total bill and tip. Clearly, as the total bill increases, the tip increases as well. Uh, but we will increase the size of the scatters to get a much better look at it. For that, we can use the S parameter. Now it looks much bigger. We can hardly make out the dots here in this area. So we will use an parameter called edge color for this. Now the scatter points are a lot more clear, but we will can increase the width of the, or we can decrease the width of the outline as well. For that we will use the line width parameter. For that you can write the line width in full, or you can use the shorthand method of LW as well. Here, so it looks good now. Next, move on to the Plotly graph for the same visualization. Yeah, so we plotted the scatter plot by using the x value and y value. But here what we got was line in place of dots. And for that, we have a mode parameter. If you check the signature, here we have a mode parameter. And if you go down to check the options given for that, yeah, so we have this options here. By default, it is drawing lines here. We can change that to markers and that should work. But apart from that, if you want, we have different options as well where it could plot line versus line and markers together, and then lines and text, markers and text, and all three. So if you go back to the line graph which we plotted earlier, if you wanted the data points to be denoted by the markers as well, then you could have selected lines plus marker for that. Here we will select just the markers mode. And also we will increase the size a little bit. So here we get almost the same kind of graph which we got here, If you look at the difference between the size parameters, for the pandas it was just the S parameter which denoted the size, and for 100 we got this big scatters. Here we have used size parameter, not just the S, and just for 20 we are getting bigger dots here. Now once again, if you look at this graph, you can zoom into particular data points. You can also pan this and move across at different coordinates, and then you can zoom again at this area and read the graph in a lot more detail and explain different data points. Also, if you hover over the actual scatter points, you will get the data points for that as well. So that is $10.07 as the total tip and $1.83 as the tip for this one. Now let's reset this. Next, we will move on to the bubble plot. So bubble plot is just the same scatter plot, but here the size of the scatters itself can be varied based on a different data set as well. So rather than denoting the relationship between just two data columns, just two data sets, the bubble plot can be used to show the relationship between three different data sets. So it's the same graph which we had for the scatter plot here, but here the size of the bubble varies and it becomes bigger and bigger based on the size of the data in the size column. That is, if it had a bigger number, then you will get bigger bubbles for those, and for a smaller size group you will get smaller bubbles. So this kind of graph is really useful for comparing things like GDP of countries and so on. This is really useful in projecting relationship between three different data sets in just one graph. And just like the scatter plot, again, once again, you can zoom into the graph and uh, study or show individual data points. You can again pan out, pan in. You have all of these options available here. Now next, let's move on to our next graph, which is histogram. Now remember, histogram is for univariate data. That is, for one column, it shows the distribution of the data just for one column. So as you can see, for both the pandas and for plotly method, we use almost the same code. We selected the total bills column and used the dot plot method and dot iplot method, and we use the same parameters for both, that is kind with hist option for plotting histogram, and we put bins is equal to 20 in both the diagrams. We also use an extra parameter age color. So just like other Plotly graph, once again we have these options to zoom in and to pan. You can hover over these bins. For example, this bin goes from 10 to 14.99 and there are 63 such occurrences here. This you have to infer manually. In this bin you have to kind of analyze what could be 1, 2, 3, 4. So there are 4 bins between 10 and 20. So this bin is going from 10 to 12.5, this is 10 to 15, and among those there are about 30. So somewhere around 60 data within 10 to 15. Now next, let's move on to plotting some bar graph. So we will start with the pandas bar graph. So see what we have plotted here is on the x-axis we have put the sex, which is a categorical data, and for y-axis we use total bill. But rather than combining all of the data for males and females, the bar graph is plotting bars for individual rows, that is for all of the 244 data. So you can't infer much from this. What we could do is use a group by method. So we use the group by for the sex column and we got a warning. So we use this observed is equal to true. Then we try to do a sum for all the values. Remember, whenever you use the group by method, you have to use it with an arithmetic. So here we are getting an error that category type does not support sum operations. So what Pandas is trying to do is to do the sum of all of the columns based on the male and female data, and obviously categories cannot be added up. So we will pass in a parameter, but just pass in the parameter numeric only and make it true. So what this numeric only did was it removed all of the categorical columns, and now we can plot our bar graph on this data frame. So here we have used the kind is equal to bar, and for y we are putting total bill. We don't need to put anything for the x-axis, as that would automatically take the index categories. So we could do one thing, we could do the same thing for the days column as well. So we get our bar plot where we have days on the x-axis and we have total bill on the y-axis. So if you look here, what we got was day on the x-axis and total bill on the y-axis, and this is giving us sum of all the bills which were paid for that day. So for Thursday, the total collection was about $1,100. For Friday, it wasn't much, which is surprising. It was just about $300. Then on weekend, Saturday and Sunday, the bill was much higher than the weekdays. It was about 1750 for Saturday and about that number around 1600 for Sunday. Now we could also plot this using Seaborn. Let's try that as well. So for the as Seaborn bar plot, we need to put in we need to push in the data what we need on the x-axis, the y-axis, and then we have an estimator parameter as well, which is basically the arithmetic we want on the bar plot. So let's just check for this. We have the same bar plot. We have days on the x-axis and total bill on the y-axis, but the values are different here from what we got here. The difference was here we have taken the sum of all the rows, so we were getting total bill for each day, whereas in this bar plot we are getting an average of all the bills. So if you want to take the sum for every day using the Seaborn method, you have to use the estimator parameter and use sum for that. See, now we are getting the same result we got for the pandas method. So for Thursday we have about $1,100 of total collection. For Friday it's about 300. For Saturday it's about $1,750, and it's about $1,600 for Sunday. Now let's do this using the Plotly method. So here if you look closely we are getting about the same number. It's about $1,100 for Thursday, about $300 for Friday. For Saturday it's about less than 1800, which was about $1,750 in our last diagram, and this is just over 1600 for Sunday. See, if you compare this graph with our original pandas graph, we were getting a plot for each of the rows. It didn't automatically clubbed in the categorical data on the x-axis, so we had to use a group by method for that. For Seaborn we didn't need to do that. It automatically grouped the data categorical data on the x-axis, but we had to use an estimator parameter to get the sum of all the bills, as by default it was giving an average of all the rows. For Plotly as well, it is automatically able to group by all the categorical data given on the x-axis, and it gives a sum of all the rows. So here in the Plotly you can actually study these individual bars, and you have all of the individual data columns added up on top of each other. So you can do that. However, if you don't want to do that and you simply want to see data for multiple columns, you can use the group by method here as well. And then pass in a list for the y-axis. See, we got a beautiful visualization here. So on the x-axis we have the days, categorical data, and on the y-axis we have data for total bill, for tip, and for size. So basically for all the numeric columns. Now let's say you want to read just the data for the total bill, so you can switch off tip and size here. This was not possible in the pandas visualization. Now we have just the columns for the total bill, and this is much bigger in size. If you want to compare this with other data as well, you can remove total bill, and let's say now we want to compare just the tip with the size. So here you can see a close relation between the tip and the size. On Thursday there were total 152 customers and they gave $171 tip. So the tip is always slightly higher, very slightly higher than the total number of people who walked into the restaurant on a given particular day. So on Friday there were 40 people who walked in and their tip about $52. On Saturday, there were 219 people walking in and tipping about $260. On Sunday, 216 people tipped about $247. So you have this option to select and unselect individual columns here. And of course, you have your usual options as well where you can zoom in at a particular day. Let's say you want to study the Friday data, and then if you want to pan across and go and check the data about Thursday, you could do that. If you hover over the individual plots, you get the data. You have all of these options here in Plotly. Now next, let's move on to the box plot. Now box plot is a simple graph where for all the numerical columns, uh, this will plot a box plot. So as you can see, using the pandas method, this kind is equal to box has automatically removes the categorical data as that doesn't have any numbers in the column, and just for the numeric data it has plotted a box plot for each of the numeric data columns. Now let's try the same thing using the plotly method. And we have our final graph here. If you hover over the graph, we get all of the quartiles here. We have the minimum, we have the Q1 value, median value, Q3 value, and maximum value. Similarly, if you go over this box plot or for the size column, you get to know that median was 2 people walking in, max to max there were 6 people walking in, minimum was 1. Of course there would be outliers as well, and those have been ignored in this iPlot method, I guess, while those are indicated on the pandas box plot. But here if you go over the median line, you don't get to see the actual value. You have to kind of assume that this would be around $17. Now of course in the plotly method you can zoom in and then you can pan across. So next we have surface plot. This we could plot only using the plotly method. We don't have this in pandas actually. So for surface what we could do is we can take just the numerical columns here and then use the surface argument with the kind parameter. This is a three-dimensional plot. If you select the plot, you can change the directions from which you want to view this. We can also change the color scheme. So we use the color scale parameter and we use this red, yellow, blue option given. So you can Google for Plotly color scale and you will get the link for the Plotly website where all of the available color scales are given there, and you can choose whichever you want to use. Let's try to produce another surface plot using a different data frame. Now this is a made up data frame where we have proper numerical values in all three columns. Let's try to plot a surface plot using this data. See how nice this surface plot looks. It's a conical data, but if you want to look at the bottom of this cone, you see it's a hollow cone. So this is where the real benefit of using an interactive visualization tool like Plotly comes about. Something like this could be really useful in engineering projects as it produces three-dimensional view of the object. Just like we have pair plots in Seabound, we also have something called scatter matrix. Let's see the pair plot first for our actual data frame, that is the tips data frame for today, and then we will see the scatter matrix for Plotly. Now keep in mind pair plot can take some time for large databases. It produces joint plot for each pair of the numerical columns in the data frame. So we have total bill, tip and size on the x-axis, and we have total bill, tip and size on the y-axis as well. So the diagonal would be for univariate data. So it has plotted a histogram. Off diagonal plots are scatter plots for bivariate data. For example, this is tip on the y-axis and total bill on the x-axis. And as you can see, as you go along the x-axis, as the total bill increases, the tip increases as well. That is the general trend. So next, let's try to plot this using Plotly. So to use the Plotly method, we need to select the numerical columns first, and then we will use the scatter matrix method. Now see here, this Plotly graph, it's almost the same graph. We don't see the title on the x and y axis, but you can pretty much make out it's between total bill, tip and size. And similarly on the y axis, the top one would be total bill, tip and size. And you can compare the graph, it's pretty similar. The only difference here in the Plotly is this is an interactive graph. So you can zoom in and you can do that individually for each of the matrix here, for each of the grid here. Then of course you can pan across. You can download this image if you would like to present it elsewhere, and then you can go back, reset the axis using a single button. So that's all for today. Thanks for watching.